Okay, so in today's ICP, we will be using uh, a Nltk to perform a Twitter sentiment analysis task. Um, so yeah, so first we're importing our basic libraries, importing Nltk tokenizers and the popular library. Then we're reading in the data from the GitHub Twitter account and throwing that data up so we just know what it looks like. It looks like there's some different kind of characters and user tags that we're gonna want to clean up. So there's no null columns or rows, which is good. And we want to take an initial look at kind of our frequency distribution so we can import some NLTK libraries to help us do that. Um, So here we have a sample graph and we can see like hashtag is the most frequent, which for our task isn't really that useful. Same with like at. Um, and we also have some stop words. So like the, to, a, like those words aren't useful to us. So we're gonna wanna clean those up. So the first thing gonna do is we're gonna extract our features. So our features are the second row, which are the tweets themselves, and then our labels are the uh, first column, which are I guess second column, and that tells us if the tweet is been flagged as hateful or racist. So let's start by deleting user. We just use a regex replacement here, or I guess list comprehension. So now we can see the output. There's no user. Um, Again, we're going to try to clean the data. We get rid of our punctuation um, using some string functions. Um, so once that's done, we want to clean up the stop words and any words that contain numbers. So we can do this using the NLTK tokenizer. Um, So when we run our words through the tokenizer, we're gonna get a list of words back. So here we're tokenizing each tweet, and then we're making sure that each word in that tweet is not in stop words and that it's also an alpha word, so there's no numbers in the word. And then this is what the output looks like. So scroll to the top. We can see father, dysfunctional, selfish, drag his kid, dysfunction, run. So we kind of got rid of all of the like the A's and does and any numbers that were in that tweet and punctuation. So next we're gonna limitize. This kind of takes the place of stemming. Um, we're using a WordNet limitizer, and so we want to get the words in their purest form. So again, we just kind of iterate through those tweets, through the list, and um, we get an output similar to before, but um, everything's in their base form, and it kind of makes the data set more distinct. So now we can take another look at our frequency distribution, kind of same code as before. We can see we have some useful words that are the most common. So like love is now the most common word, which is good. That's what we want to see. And then again, using the code that we got in the ICP, we are just making a word map to show the most common words. So next we're going to do some part of speech tagging. So we tag the text, which comes out an output like this. So like NN is a noun, JJ is an adjective. Um, and then to be able to run it through our model, we need to input sentences. So what we did was um, concatenate the words and the tags together into one long word, and then joined all the tweets together. So we have an output that looks like this, where there's an underscore uh, part of speech tag. So it's word underscore part of speech. Um, Now we can run this through our model. So our model is a scikit-learn. We split the data into test and training. Create a pipeline with a TF-ID, F vectorizer, and a linear support vector machine. Um, Creating the pipeline is here, and then we're able to fit the data, train our model, make our predictions, and now here we can evaluate the model. So we have a pretty good precision, some pretty good numbers here, and that's it.